Hello, good morning everyone. Welcome to the webinar on natural language processing using Python. I am Sulekha Alu Ravi. I'm a passionate data enthusiast. I'm also an alumnus of Great Lakes. I work as an AVP in an international bank. So by the end of this webinar, you will learn an introductory overview of natural language processing, applications of NLP, implementation of NLP using Python at a beginner level. So what is meant by NLP? Let us see what is natural language first. So we are all aware of what is a natural language. It is any language that is used for our everyday communication by human beings. So languages such as English, Hindi or Telugu, all these are natural languages. So by natural language processing, we mean communicating to an intelligent system using a natural language. So what does this NLP help us to do? It enables computer programs to understand unstructured data, I mean unstructured text, by using machine learning and artificial intelligence. It also helps us to make inferences and provide context to language. Just as our human brains work, NLP also works behind the screens. So NLP is a great tool for uncovering and analyzing the signals buried inside unstructured data. All right. So where can we apply it? We communicate to our smartphones on a daily basis using natural language. So all the speech recognition and handwriting recognition applications that we are using are built based on NLP. And also applications such as Google Translate, Amazon's Alexa, Google Voice Assistant, and Apple Siri, which most of us might have used at many instances. So all these applications are built on NLP. We'll focus on applications of NLP in banking industry. So let us see some of the examples where we can effectively make use of NLP. The first application is virtual customer assistants or chatbots. While logging into online portals of banks, you might have come across a virtual assistant chat window, which usually starts with a question of how may I help you? These chatbots are pertinent. These are basically the pre-trained historical logs of conversations. So these chatbots, what they do is they take up the historical logs of the conversations which happened before from the customers to the bank, and they train using an NLP technique, and they use some combination of steps and patterns to convert the customer's text or speech into structured data, and those data is then used in turn to select the suitable answer based on some of the machine learning algorithms. This is how a chatbot usually responds to your question. Even though there is no person behind, you still get some relevant answers to your questions. And the next application is analyzing banking documents and extracting information from them. So banks end up with huge quantities of documentation for various purposes, such as regulatory purposes, and there will be a lot of KYCs that happen, etc. So if they don't choose to take a disciplined approach to classify and manage these documents, then it would have a huge cost impact on storing and retrieving these documents for later use, etc. So NLP helps in handling this problem by streamlining the document classification and to perform analytics on the documents whenever there is a requirement. All right. The next application is analyzing conversations about a product or service. So banks also hold a huge log of customer conversations in the form of audio data. So whenever we make a call to a customer service in a bank, we get a message that this conversation will be recorded, right? So all this data, when it is stored, it becomes a great source for understanding customer sentiments. And it helps the bank to analyze the sentiment of customers on various products and services offered by the bank. NLP helps in conversion of audio data to text and to perform further analysis on understanding the complaints or feedbacks from the customers and taking further actions to improve the bank's service delivery. And the next application where we can use NLP is gathering real-time intelligence on stocks or on the company data, etc. So there are many news APIs which you might have used in different instances, or you might have come across it. So these are the APIs which are available to crawl the news on real time and apply NLP techniques on them to understand the customer affairs and the status of stocks and status of the annual reports or financial data of companies and the latest current affairs and news on the companies, etc., which are being traded by the banks on behalf of their customers. So applying machine learning and NLP helps in real-time market research and taking strategic decisions on investments. The next application would be in monitoring sentiments. So, while majority of the news, such as annual report or mergers or acquisitions, these affect how investors view a company. So, similarly, even the general tone of the news coverage and the social media sentiments can have an impact on the markets. So, NLP helps in converting public opinion into sentiment factors, which can further help in taking strategic decisions by a bank. And the next application would be anticipating customer concerns. So we know that we do gather a lot of audio logs as part of banking data. And all this, and also we gather a lot of additional information from social media forums such as Twitter, Facebook, wherever people are stating their opinions on a particular product or a service from a bank. So all this information can be used um, by applying NLP algorithms, and it helps us to discover and parse the customer sentiments and anticipate concerns on a particular product or service. This can help banks take proactive measures and to mitigate the risk of a future failure on a product or service. Uh, so these are various areas where we can make use of NLP in a banking industry. So in the upcoming slides, let us also look at the actual concepts behind this NLP and the implementation of NLP using Python. Here we are going to cover the NLP concepts. These are the some of the important concepts which we need to know to apply NLP algorithms on text data. The first one here is text processing, then tokenization, normalization, stemming, bag of words, POS tagging, and classification. Let us look at each of this in a detailed manner. Text processing. So what is meant by that? We're all very familiar with the text because we use it every day to read and write. And NLP treats this text as raw data. The most important source of text is undoubtedly the internet. So we gather humongous amount of text in the internet, and the functions and parsers that are available within NLP algorithms and libraries, they help us to access this text. So we'll be able to access the text either from the local directories or from the websites and process them using these various algorithms. So text processing would be the first step to start building NLP based models. And the next concept is tokenization. So what is meant by tokenization? To state it as a definition, we can say that tokenization is the process of cutting a string into identifiable language units. What exactly is this? In simple terms, we are splitting a sentence into words using separators, such as in a sentence, every word is separated by a space, or it can be separated by tab if it is in the form of an Excel sheet or something. And there might be new line characters which are separating the text. So if you are using this kind of separators and separating your sentence into words, it is known as tokenization. The next concept is normalization. What is meant by normalization? So when we say normalization mathematically, it is your bringing your data into a common scale. Similarly, when it comes to the context of text, converting the text into a common scale for further processing is normalization. Okay, so for instance, we need to convert all uppercase words into lowercase words for the ease of manipulating the text in the further machine learning models. In that case, we normalize our text into all lowercase words. Or we have a lot of abbreviated text in our data. So we need to expand it, convert it into the full form, and then use it in our further processing. So that can also be called as normalization. In case we are handling different kinds of data, for instance, the fruit, apple is a fruit, but apple is also an organization name. So if you want your text, if your data set has this term apple and it implies the fruit and not the organization, then your algorithm should handle it as a fruit instead of an organization. So these are the kind of functions which we can program within the normalization. So there is no single method to normalize the text. Knowledge of the context in which you are applying NLP is very important in programming the normalization logic. The next concept here is stemming. So what is meant by stemming? To make it in a simple term, you're just stripping off the prefixes and suffixes of your text according to your need. You're just stemming the text. That is known as stemming. So similar to normalization, stemming also don't have a single method or process. We can do it in any method according to the application where we are applying stemming. The next concept is bag of words. What is meant by bag of words? So when we say a bag of words, you have a huge set of data, which is obviously a huge collection of words. And you're trying to identify the potential features in that complete set of data. So in text analytics or in natural language processing, your features in the data would be the words which you are using within your text data. So this bag of words is a feature extraction technique where a sentence is split into words similar to tokenization. But in the bag of words model, the number of occurrences of each word is maintained in a dictionary. So it will be stored as a key value pair. for instance. So the key would be the word which occurs in a sentence, and the value would be the number of occurrences of that particular word in your data. So after removing grammar and stop words such as conjunctions, prepositions, etc. from the sentences, we form a corpus out of the complete set of valid words within your text data. That is what is performed by this bag of words model. So once a corpus is formed, these words are converted into feature vectors. So feature vectors, what is meant by this? Every machine learning model, it basically accepts data in the form of numbers. So when you are converting this data into bag of words, then it becomes a vector. Uh, for instance, we have 20 reviews on a product in our data set, and there are a total of 20,000 unique words in the complete data set. And if you are creating a n by m sparse matrix with reviews as n and the unique words as m, and then you are populating the number of occurrences of each word as the matrix table, then it is called as a feature vector. And this concept is also known as word to vector featureization technique, where you are converting your text into numbers, and the numbers are the ones which any model can understand. The next concept is POS tagging. So please keep posting your questions. I'll answer your questions once we go to the Q&A section. Yeah. So the next concept which we are going to cover is POS tagging. And I'll also be explaining the example of how we'll implement it using Python. So we'll be looking at it in the Python code for those who are having questions related to the concepts which we are covering now. Yeah. And okay, coming back to POS tagging, the process of classifying words into parts of speech and then labeling them accordingly. This is known as part of speech tagging, which we have been learning in our English grammar classes. So it is the same thing and nothing new. For example, let us consider a sentence. I am satisfied with the customer service. So this is the review which customer has posted. So if you are doing a POS tagging on this, then I would be a pronoun, am satisfied will be a verb, with will be a preposition, and the will be a helping word or determiner, and customer service will be a noun. So we are tagging text to its part of speech, and it can help the machine learning model to determine the weightage of each word and handle feature vectors accordingly. And the last concept here is classification. So now that we have done a lot of processing on the text, we have processed the raw data, then we perform tokenization, then normalization, then stemming, then converting it into bag of words, and then tagging using parts of speech, etc. So once we do all these activities on the text, the final thing will be to feed it into a machine learning model and train the algorithm. So this classification part is where we are choosing the correct class label for a given input. For example, let us consider when a new customer gives a review stating, I am not happy with the customer service. So by looking at the statement, we can understand that this is a negative sentiment from the customer's side. So what this machine learning model, a classification algorithm such as a supervised learning machine learning algorithm, what this algorithm will do is it will look at the patterns of similar to, such statements from different customers in the past. And it will classify this particular statement, I am not happy with the customer service, as a negative sentiment. So application of all these concepts together would become a natural language processing algorithm. Now that we have seen what each of these concepts means, now we'll go to a case study. So this looking at a case study would help us understand the concepts better. So let us take a simple case study where we'll cover the subset of these concepts. We will not be covering all the concepts in detail because at a beginner level, we'll cover how we can handle text using NLP. Okay. So to demonstrate a case study of NLP on banking product reviews, I have downloaded Bank Bazaar reviews on personal loan across all the banks. And I'm going to apply some of the NLP techniques to predict the customer sentiments on personal loans offered by the different banks. Let us look at it first. Let us see what kind of data we are going to deal with. Okay, so I have just gone to bankbazaar.com website here, and I have chosen ratings and reviews and the product type as personal review. If you look at this page, you can see a lot of reviews posted by different customers. And there are many pages here, 1 to 63 pages are there, pages of reviews are there. So what I have done here is I have stored each of these reviews as HTML pages. So if you see here, I have stored from page 1 to page 50. I have stored all the reviews here. We are going to now access these reviews and apply NLP using Python. Okay. So the interface which I am currently using to do this exercise is called as Jupyter Notebook. And before going through this exercise, let us see what are the steps we are going to follow here. Okay, so these are the simple steps which we are going to use to implement this case study. First, we are going to load the downloaded HTML files which we had stored in our local directory. And then we are going to use a library called Beautiful Soup, and we are going to parse this HTML file. And then we are going to convert the data into data frames. So for converting data, there is a library called pandas in Python, and we are going to use that library. Then we are going to write a simple sentiment analysis function just to define the sentiment based on the ratings criteria. And then we are going to split the data into train and test. We are going to do it at a 70/30 ratio. Then we'll use one of the feature extraction technique called TF-IDF. So in our NLP concepts, I was explaining about bag of words. Bag of words is one of the techniques for feature extraction. Similarly, we are going to use TF-IDF here. So while we are running the code, you'll be able to understand what it is. And then we are going to build a simple machine learning model. So we'll be picking one of the machine learning models and we'll build it. Then we'll create a confusion matrix to check whether our model has performed as expected. Then we'll see what is not correctly predicted. And then we'll think of alternative approaches, how else we can do it. So going back to the Jupyter Notebook. First, we are going to load the reviews in the form of HTML files. So I'm going to use a library named as glob. Yeah, so what this glob will do is it will parse all the directories and subdirectories, and it will take the HTML files. So since we have only one directory here, Bank Bazaar data, we are going to use Bank Bazaar data and we are going to parse all the HTML files using store.html. So once we run this, all the HTML files get loaded into a single document. I mean, we'll get the path of all the HTML files first. Then we need to read the HTML files. So if I am just executing this, we can see that now all the HTML file path has been read inside this list. Then we'll import the codex. So we are importing codex because we need to read the files and we need to parse them and store them as a HTML array or a list. So what I have done here is I have added a separator called space and I'm clubbing, reading all the HTML files and appending them one after the other by a space character. So now we got a single HTML file which is a combination of all the 50 HTML files. And to look at what is inside the HTML file. If you are running the HTML file here, it will be a huge document and it might hang. So what I'll do is I'll count the reviews inside the HTML file. So there is a class called ellipsis underscore text in the HTML file, which is used for storing the reviews. So I'm going to just count how many reviews are inside it. So there are 996 reviews inside this HTML file. Now let us parse them using Beautiful Soap. So Beautiful Soap, what it will do is it will parse the HTML tags, it will extract, it will find all the reviews and it will store it inside an array. So using this function, Beautiful Soap HTML and HTML.parser, I'm going to parse the files. This will take a moment. So once we get a number displayed here, it means that the code has executed successfully. So it is still running. We'll have to wait. Okay, so some of you are asking me questions on how would we know that ellipsis text is part of the HTML. So let me just open HTML, a random one. Yeah. I'll just view this page source. Okay, and I'm going to search ellipsis underscore text. So if you see here, under the class ellipsis underscore text, we have all the reviews. So the same tag and the same class has been used across all the HTML files to store the reviews. And the item prop for this particular review is description. So whenever you have this tag, this attribute item prop and description is available, and this attribute class and ellipsis text is available, we are finding all these values in the code and then we are parsing it here. So now the parsing has got executed. Yeah, and those who are asking me the question, so is Beautiful Soap a Python library? Yes, it is a Python library. And Jupyter is an open source software. Yeah, you need to download Anaconda and you can download the latest version. Yeah, and Jupyter is basically an interactive interface where you can run your Python code and look at the results then and there rather than running it from the backend. Yeah. So now what we have done, we have passed all the reviews inside this reviews data. I mean reviews array. If you look at this reviews, so we got all the reviews populated here. I'm just going to delete it. Okay, similarly, we are going to populate all the ratings. Rating is having an attribute item prop, and the rating value is the name of the attribute. So we are going to parse all the ratings and store it inside the rating array. So once we store the ratings, we can also check how the ratings are displayed here. So here we got all the ratings 5.0, 3.0, 4.0, etc. Right. Okay. So the question, GPU is needed or do we need CPU? We can make use of CPU for running this. So each library, we need to download all the libraries. You can download the libraries using pip install. Pip install with the library name. So for Beautiful Soap, the name of the library is BS4. Now we are going to add a library called ORI. So what this library would do is it will handle the regular expressions in the text. And we have a small function here called clean HTML. So if you look at this function, we are doing a compilation, re.compile of this is the syntax less than dot star question mark and greater than. This is how a HTML tag usually looks like, isn't it? So we are going to take all those uh, contents which are inside a HTML tag and we are going to remove them. And once we clean the HTML, we'll get only the ratings and the reviews as part of our data output. So we are cleaning the HTML here. Then if you look at this, there is an array called rates. So inside this, we are going to store all the ratings. So we are parsing the ratings and then we are cleaning all the rating content and we are taking only the values 5.0, 4.0, 6.0, sorry, 1.0, 2.0. These are the values which will get stored inside rates. So if you look at rates now, previously while we were seeing ratings, we had HTML tags and in between that we had the ratings. Now it has been cleaned up and we got just the rate values alone. Yeah. Similarly, we are going to do the same activity, cleaning the HTML file on the reviews. So once we clean the HTML tags in the reviews, our reviews would look like this. So we got the text directly. If at all there are any other special characters here, it is the /n character which we can see the next line characters. So we need to clean that as well. So let us see how we are going to clean that. Now we are going to import pandas. Pandas is a library which is available by default in Python, and this is a great library for handling all kind of data. So what this library will do is it can convert the data into a table format, which is called as DataFrame. And then we can do our further processing and everything on that table. So now what we are going to do, we are going to create a data frame called reviews. pd.dataframe. This is the formula which we are using to create a data frame. Inside it, we have reviews as one column and ratings as the other column. And for the reviews column, we are going to store the reviews array which we created in the previous step. And for the rating column, we are going to store the rates array which we have created in the step 16 here. So let us run this and see what happens. Yeah. Now that I have executed reviews, let us see what is inside this reviews. Yeah. Now we got two columns. One is ratings and the other one is reviews. Okay. But still we did not handle the /n special character in the previous clean HTML step. So we need to handle that as well. Yeah, so Satyajit, yes, we are going to convert this string into float. I'll explain it in the next steps. Yeah, okay. So first we'll replace all these slash n characters. We'll remove them from the data. And then next we'll drop all the duplicates. If there are any duplicate records inside the data set, we don't need them for our model building process. So we are just going to drop all the duplicates using this function called drop duplicates. And then let us count the number of reviews and see. It is 992 reviews in total. So previously, while we did a count, it was 996, which means there are 4 duplicate records which got removed after dropping the duplicates. Now let us look at how our data looks like. So reviews.head, when you are using head and you are giving a number inside it, you can see that many records in your data set. So now we are looking at first 5 records with ratings and reviews. So in order to do further manipulations on the data, first we need to see whether we are using the correct data types in our data. So I'm looking at reviews.dtypes. This is a function which will give you the data types. So this first column ratings is of type object, but it is actually a number. As we can see, it is a float number, right? So and when we look at the column reviews, the second column, it is text. So it being an object is still fine because it is still handled as a string. Now first let us convert this ratings as type float. We are just going to convert the data type and then we are going to look at the data types. So now we have ratings as float and reviews as object. Okay. So when we see the process flow here, we have completed loading the HTML data, parsing it using Beautiful Soup, converting the data into data frame, calculating the sentiment. That is the next step we are going to look at. So how we are going to calculate the sentiment? We are not going to use any complex steps here. We'll just keep it simple. We are going to look at the ratings which are less than 4.0. If the rating is less than 4.0, it is like rating from 1 to 3.5. So all these ratings will be considered as negative sentiment, and all the ratings which are above greater than or equal to 4 are going to be considered as, yeah, greater than or equal to 4 are going to be considered as positive. All right. So if we look at, we'll run this function first. Yeah. And then we are going to apply this calculate sentiment function directly on the data. So this is the best part of Python pandas library, where we can apply, we can just write a single function, user defined function, and directly apply it using the apply function here, which is available in pandas, and we can convert the data according to our requirement. So what I'm doing here, I am creating one more new column called sentiment inside the reviews table or the data frame, and then I am applying calculate sentiment. So what this calculate sentiment will do, it will check if the rating is less than 4, it will make it as negative. If it is greater than or equal to 4, then it will make it as positive. So let us run this. And now if we check the contents of our reviews data set, so we got one more column called sentiment added at the end. And if the review is negative, it will be 0. And if it is positive, it will be 1. For safer side, what I have done here is I have just stored this complete reviews data frame into a CSV file. So in case in future, if you want to make use of the same file for training the data, you don't have to rerun the previous steps. All of the previous steps can be avoided and you can directly use this data to train the model. So once you do this reviews.to CSV, a CSV file will be created in the folder where we are running the code, running the Jupyter notebook. So if I just open this, So now the complete data has been stored inside a CSV file. All the records are available here. We can directly use this by making use of pandas.read underscore CSV function, and we can directly read the data instead of doing all this parsing beautiful soup and all of the previous steps. Okay. So now we are going to do the actual part of building a machine learning model. So machine learning models are basically supervised and unsupervised learning models, which will train the data by identifying the patterns in the data, and based on the training it will learn what is inside the data, and based on that, when we are giving a new data as the input, it will test the data, and it will classify the data according to our requirements. So I'm not going to explain the machine learning model as such in detail, but this is the concept. You can remember this concept, and I'll tell you which are the libraries where you can find the different machine learning models and how you can use them in NLP. Okay, so now we are going to store the reviews and the sentiment. We are not going to use the ratings column here. We are just going to use the review column and the sentiment column, and we are going to store it into two different arrays here. Text is the array where we'll store all the reviews, and Y is the array where we'll store all the sentiments. Okay. So once we store it inside this, if I'm just typing text here, and let us see what is the type of this text. It will be in the form of a series data. Similarly, Y also will be stored as an array or a series data. Okay, so now next step, we are going to split the data into train and test at a ratio of 70/30. What is meant by this? Why do we need to split the data? So now that we got our complete data set with 992 records in it, and all 992 are reviews. Okay. So we need to feed an input to the machine learning model from which it will understand, it will learn looking at the patterns of the data, looking at what are the kind of text that is used in each review and how many times it has been used. Based on that, how it is classified as a positive or negative sentence. This is what the machine learning models are going to learn from our data. So in order to do that, we need to first train the model. Then we have to test the model. For training the model, we are going to use a library called scikit-learn, and within that we are going to use a class called model underscore selection, and we'll import the function train test split. So we don't have to manually split the data into 70/30. If you are giving a random seed on a random criteria, the data will be picked from the data set, and it will be split into X and Y, which is test and train, which is at the ratio of whatever we are giving as input here. So the test size we have mentioned here is 0.33, which means 33% of the data is going to be a test data, and the remaining 67% is going to be the trained data here. So let us run this. Once we run this data, let us explore what is inside this train and test data. We can directly run this and see what is inside text and train, text underscore train. So if I just run it, I can see that. And if you look at the left side, the index here, right, it is not a proper sequence because it is a random split. It'll not be 0, 1, 2, 3, etc. It is taken on a random basis. Similarly, if you look at the test data also, it will be split randomly. So the data is split randomly in test data as well. Okay, now let us explore the content. So how many records are inside train, and what is the positives, how many are positive and how many are negative. So let us just look at it. Okay, so the unique values inside y underscore train here is 0 and 1. 0 is for negative and 1 is for positive. Similarly, the unique value inside y underscore test, let us see, it is also 0 and 1. So we have both the positive and negative sentiments split across both the train and test data. This is very much important because we need to have a proper distribution of the classes inside the data. Only then we will be able to train the model effectively. Okay, so the number of samples per sentiment, we can see it by running this. We have 136 negative sentiments and 528 positive sentiments in the data. So similarly in the test data, we have 68 negative sentiments and 260 positive sentiments. So at a ratio of 70/30 with the available data, the split has been pretty decent. So let us proceed further and extract the features from this data. So if you remember, I was explaining about the bag of words model, where we can create a corpus of the unique words which are used across the data set, and based on that corpus we'll create the features in the data by creating a sparse n by n matrix in it. So another technique which we can use here is TF-IDF. TF-IDF is known as term frequency inverse document frequency. So what is meant by this term frequency inverse document frequency? So if you look at the formula here, we have calculated the TF term frequency first, and then we are multiplying it with the log of n plus 1 divided by nw plus 1 plus 1. Okay, to mention this in simple terms, TF means number of times term T appears in a document divided by total number of terms in the document. So log of IDF, what we have done here, inverse document frequency, which is we have taken the log of the total number of documents divided by number of documents with the term T in it. So this will basically create a weightage for each word. So for instance, I am using the word happy. There will be a weightage for the word happy in my review. I'm using the word dissatisfied. There will be a weightage for it. I'm using the word good. There will be a weightage for it depending on this TF-IDF formula. So do we need to write this particular function from scratch? No, we don't have to write it. We again have it inside scikit-learn feature extraction text. And then we can import the function TF-IDF vectorizer to convert our data. So let us run this. So what this will do is in the bag of words model, I mentioned that we'll create a sparse matrix of the data. The number of reviews will be in the n axis, and the number of uh, features, unique words will be in the m axis, and you will fill it with the number of occurrences. So it is an n by n sparse matrix. The same thing will happen in TF-IDF as well. So let us see that here. We are going to use the function TF-IDF vectorizer, and we have the minimum document frequency, normalization, all this whatever parameters we have here. You just can select the function, click on shift and tab, and then click on this plus sign. You can see the explanation for each parameter inside it. So if you want to use stop words such as is, the, of, for, I don't want to count all this as my features. So just remove them from my corpus. So if you want to use those kind of stop words, you can store all those words in a text document and then load the text document here. So you can do a lot of variable customizations on creating a feature vector. So once I have executed this TF-IDF function, let us now convert our train data and our test data into feature vectors. So I'm just going to directly use this function on my train and text data. And after doing this, if I'm running this TF-IDF train features, okay, so there are 664 records in my train data, and there are 1148 unique words which have been chosen by the TF-IDF model, and it has created a 664 by 11448 sparse matrix. Suppose I want to look at the data inside it. This is how the data will look like. So on each and every record and on each and every word, this TF log n plus 1 divided by NW plus 1, this formula has been applied and we have got floating point as the output here. Okay. Similarly, we have done the same thing on the TF-IDF test features as well. So we have 328 records in total and 1148 features in it. So we have got a 328 by 1148 sparse matrix as the output. Okay, so someone is asking me how voice recognition is done by NLP. There are many libraries which are already available within Python, which can convert your audio data, which is in the wave format, um, based on the Uh, for instance, if we take up the Google speech recognition, there is a library called speech recognition. So you can import that particular library, and there are functions which can convert your audio data from any language into the text data in any language you want to. So you can make use of such inbuilt libraries. Okay, so from now, once we have done TF-IDF train and test features, once we generate it, we'll also add few more functions here. First, to calculate the metrics. So what is meant by metrics? Now I'm just running this metrics function. Right now, I'm not going to explain what this metrics function will do. Once we apply our machine learning model, we'll be able to understand what this particular function will do. So here we have written a function called train, predict, evaluate, and evaluate the model. So what is meant by machine learning models? So we know what are machine learning models since we just have a one-line explanation previously in this session. But there are machine learning models can be either supervised or unsupervised models which can learn from the data and identify the patterns. There are various supervised learning algorithms such as there are many regression and classification algorithms, and there are algorithms like multinomial naive bayes and a decision tree, random forest, etc. So all these algorithms are working with the background of mathematical calculations and probability and statistics inside them. So let us not go into the details of those algorithms right now. We'll see how to use those algorithms here. So this is a train, predict, and evaluate function where we are going to have a classifier, and we are going to take the training data as the features as our training input and the labels of the training data, and we are going to take the test features and the labels of the test data as the input. And let us see what it does. First, we are going to build the model classifier.fit. So you are going to take a classifier as the input and you are going to fit the training features and the training labels. So once you fit it on the classifier, what will happen is the model will start learning. It will learn, look at the patterns, what kind of data, what kind of records have been classified into positive sentiments, what kind of records have been classified into negative sentiments. It will classify according to that, and it will learn from the data. Once we do this classification and learning, then we can predict the data by passing only the test features. We don't have to pass the test labels as input. So your test data has got 368 reviews, sorry, 328 reviews, and there are 328 sentiments in it, either positive or negative sentiments. So the sentiment column is going to be omitted. We are just going to pass the reviews, and based on the learning from the classifier, the predictions will happen on the data. and this get metrics. So this previous function where we have created a function called get metrics, where we are printing the accuracy, precision, recall, and F1 score on the data. So basically, in simple terms, what we are doing here is we are comparing the data. We are comparing the actual versus prediction, and we are giving that as the result in the metrics. So we are calculating an accuracy based on how many is actually correct, how many is predicted correctly. Now we'll train a model called multinomial naive Bayes. So this is one of the machine learning models which can take in your training data as input, and it can classify based on the probability of occurrence of the of any particular label as the output. So again, I'm not going into the actual methodology of this multinomial naive Bayes, but how you can use this particular algorithm is you can go to scikit-learn and you can select naive Bayes, import multinomial NB. This is the name of the classifier. So I'm going to run this. Okay, before this I need to run the previous one. Yeah. So let us run this. Let us import the function. Then we are going to run multinomial naive Bayes as a model, and we'll store it inside MNB. So if I'm running this MNB underscore best, okay. If you look at this, you can see the description. So multinomial naive Bayes classifier is suitable for classification with discrete features. So example, word counts for text classification. So for this kind of NLP techniques, this is also one of the suitable algorithms. And you can look at the detailed explanation and the parameters which are used inside this classifier here. So you just need to do a shift tab on this particular function and you can see the details. Okay. Now we are going to run our train, predict, evaluate model function on this data. So we have given the training features, training data, test features, test data, everything is input here. And we have an accuracy of around 78% with a precision of 73% and a recall of 78% and an F1 score of 74%. So accuracy is directly the simplest logic of where actual versus predicted, and you're taking a percentage of it. What is meant by precision? So precision is nothing but the ratio between true positive and the sum of the true positive values plus false positive values. What is meant by this? If we run the confusion matrix, okay, so we have it as there is a in the x-axis we have 0 and 1, y-axis 0 and 1. So what is in this x-axis? It is the actual values of 0 and 1, and y-axis is the predicted values of 0 and 1. So if we look at it, true negative is 12 and predicted negative is 12 here, and true negative is 12 and predicted positive is 56. So here true positive 16, predicted 244. So what is actually calculated here under precision and recall is nothing but you are taking a ratio of true positive divided by true positive plus false positive in the precision, and in the recall you are taking a ratio of true positive divided by true positive plus false negative. So why am I using naive Bayes and why am I not using other model? So I just wanted to show one of the examples. So I picked naive Bayes here. Naive Bayes is not the only model which you can use. You can use any other model as well. So since it is a classification, you can also try it with a decision tree, or you can try it with SVM, etc. Any other model you can use any classification algorithm here. Okay, so now we are seeing numbers all over here, and there is, I assume you would have got a bit of clarity on how we can handle text using various machine learning algorithms. I mean, how to handle text using natural language processing. So now let us see what is actually in the output and how can we see that with the actual output. Instead of looking at numbers, I have just written a small function here which will take in all our test data and the test labels and the prediction algorithm. I mean the prediction values from the the predicted labels. So if we look at the output here, we can see that actual label is 0 and the predicted label is 1. So actually the sentiment is negative, but in the prediction the sentiment is positive. Why is that? If we read this one, my personal loan was taken with Fullerton. The process was very good, but their processing fee was very high. So actually, if you look at the term very good, and there is a term called satisfactory, all these are positive sentiments. So the model has predicted this since many people who has given positive reviews would have used these words. Model has predicted this as a positive review, even though it is a negative review. So what can we do further? We can add weightage to our features. We can use different featureization techniques and we can try with different models. So in order to get better accuracy, we can make a lot of modifications and improvisations and regularizations and this kind of classification models. So this is a simple example of how you can apply NLP in an end-to-end process. Okay, now that we have seen an example and we did not use a library called NLTK. There is a library called NLTK in Python, which is the best library for handling all this kind of NLP algorithms. So you can make use of, you can try with downloading this NLTK. And if you go to nltk.org, there is a book as well available where you can look at the examples and understand the concepts which we explained here. And you can try it out and understand more on how natural language processing happens. So and both the code and data that are available in this session are available in my GitHub repository. So you can just go to github.com Sulekha Alur Ravi / natural language processing and you'll be able to download both the code and data. So let us see if we have any other questions where we can answer. Yeah. Okay, so can you share this Python code? Yes, that is available in GitHub. You can download it. And you want me to send it to the chat window? Okay, let me just send it. Okay, I believe you would have received it. Okay, so is there any good book on NLP in the market? You can in nltk.org, if you go to this website, they have their own natural language processing with Python, using Python. There's a book which was written by the developers of this library. So you can refer through that book. Okay. So it is quite a manual task. So it is not a manual task. So what we are doing here can be handled directly by libraries which are already available in NLTK. You don't have to manually write these functions. For you to understand it for the first time when I am directly using the existing libraries, you might not get a gist of what is inside the concept of natural language processing. So I was using these functions. Okay, so Great Learning will be sharing the PPT, I believe. And are there any prerequisites to learn NLP? Okay. So if you understand Python and if you understand how you can handle text, I don't think there are any other prerequisites. So if you want to learn it in Python, high level overview of Python will help you. Okay, I'm also sharing the link for NLTK here. Yeah. Okay. Can the same thing be done using or? Yes, it can be done using or instead of Python. Is NLP coming under AI? Yes, it is coming under AI because when you are doing the text manipulation, you are making use of these functions. But when you are making use of the training and testing the data, you are going to make use of the actual machine learning algorithms because we are not manually helping the data to understand the classification. It is the machine learning model behind it which is helping it. Yes, NLTK libraries can work with any language, any human understandable language. And yeah, so the market job opportunities, there are a wide variety of opportunities available across the market because you have humongous amount of text and text processing is one of the most important area where you can find a lot of insights from the opinions that are posted in forums, etc. by the people. So market opportunities are also very good in this. So how to determine which classifier model is the best suitable model? So for that you need to do a model selection process. You need to pick the suitable models and apply it on your trained data and see how it is classifying. And based on the accuracy of the model, you should be able to uh, find out the best model. So which deep learning techniques can be applied? So there are many questions that are getting posted. I am looking at the recent questions and answering you. So which deep learning techniques can be applied to NLP? You can apply neural networks such as multi-layer perceptron, feed for forward neural networks, etc. And do we require knowledge of internal working of ML algorithms? So at a high level, if you understand the machine learning algorithms, then you don't need to acquire the knowledge of the internal algorithms. You should know what are the parameters that you need to pass for a particular algorithm, and you should be able to understand where to use a particular algorithm. So that is the kind of knowledge you will have to know. And how to manage the sarcasm text because it will be positive. Okay. So yeah, so some of the sarcasm text will be positive. You need to make use of, you need to give the weightage in your data depending on the text that you are seeing in your data. So what I would say here is you need to create certain words which you feel are sarcastic words in your data. Sometimes the models do predict those words as positive sentiments, but I feel it can be given as the inputs to identify them as the sarcastic words and as negative sentiments, and based on that, you'll be able to give different weightages for different kinds of words. Okay. So NLTK library is for NLP. There are other models which are available in scikit-learn, which you can make use of. Okay, the depending on the technology which you are using, your machine learning libraries will be used in the industry, such as, for instance, if you are using Python, scikit-learn is a library which has all the machine learning algorithms which you can make use of. And if you are using Spark, then Spark ML will be the library which you can make use of. So for each technology, you have different libraries. So Python or R, which is better for machine learning? Both are good for machine learning, and comparatively, I would suggest it is Python because uh, Python is much easier to productionize. When now the model which we have executed here, if you want to take it to the production, then Python will be the most suitable one. Yeah. Any libraries available for legal text? So there are no specific libraries as far as I know for legal text, but you can perform legal text analytics as well using the NLTK, and you can write your own customized functions on top of it. So is NLTK the only model for NLP? Not really. You can make use of NLTK because it has a lot of functions that would support natural language processing, but you can also make use of scikit-learn, and you can also write your own customized functions. And if you go to PyPy repository, you can also find many other libraries which can be used. Is 8 GB RAM and i5 processor fine for ML computation? Oh, yeah, depends on what kind of libraries you are using. If you are making use of TensorFlow, 8 GB is still fine, but if you are making use of huge amount of data and if you are doing complex computations, then you might need a 16 GB RAM. So for these libraries, 8 GB is fine. Yeah, i5 is fine. And you can also for scikit-learn, even 4 GB RAM will work, and i3 processor also will work as per my experience. But when you are going to more complex data and when you are trying to handle big data, etc., you will need a higher configuration machine. Is TensorFlow also related to NLP? TensorFlow also can be used on NLP. Yeah. Okay. Machine learning can be done with Apple Siri. So, machine learning will be the background or the basis of creating applications like Apple Siri. So, do we need to be strong in grammar or language? For example, in English, uh, not really. You can obviously take the help of Google and Stack Overflow if you feel that you're not very confident on the grammar or the language, and you can make use of Google Translator, etc. So what is the minimum configuration required for ML? The best configuration, minimum best configuration I would say is having a 8 GB RAM and at least i3 or i5 processor will help. Yes, machine learning will support unsupervised learning as well. Yes, these algorithms can be applied on other languages. So machine learning is a part of artificial intelligence. So artificial intelligence has also got many other areas such as deep learning, reinforcement learning, etc. Okay, thank you. Thank you. So the skills that will be required to learn ML is you have a high level programming knowledge, and you know any of the programming languages previously, then it will help you actually. So SAS is also used for analytics, yes, and for machine learning, yes. Okay, there are many questions that are being posted. Okay, what is the reason Python is gaining popularity? Then Oren says, because Python, if you start working on Python and if you get any questions and if you just Google it, you will get a lot of information from many websites because of the community support that is available in Python. And it being an open source and the kind of libraries, quality of libraries that are developed and tested, Python is considered to be one of the best and widely used. Yes, if you are a fresher, it will still help you. That's right. So, okay, so minimum CTC depends on the organization perspective, which I cannot comment on here. Yeah. Okay. All right. So, if you learn Python, if you already know Python or if you learn Python, then you can proceed with using various machine learning algorithms, learning the machine learning concepts and machine learning algorithms. And do we need statistics? Yes, statistics skills are required because all these algorithms are with the background of statistics. So, learning it and knowing where to apply it will be very useful. So, for 10 plus years of experience as well, there are opportunities in the industry because with your 10 years or 10 plus years of experience, you would have added a lot of skills to your profile. Along with that, when you are getting this kind of advanced skills, it will be an added advantage for you in finding new opportunities. So, okay, so you can follow me in LinkedIn. You can search Sulekha Alur Ravi. So, offering a job in ML, so what the employers will look at is your depth of understanding of the concepts and your interest towards handling data, the way you can look at data and find the insights from it, and the way you can understand the business problems and see what best can be done with it. And okay. Can I transition to data scientist role easily? Yes. So being a test engineer, it is definitely a good opportunity for you to transition to data scientist because as a test engineer, you would have done a lot of test data creation, test data manipulations, etc. Right? So that will help you in the exploratory data analysis part of machine learning. Okay, so thank you everyone. It is a very good session and you have asked a lot of good questions. Yeah, the video will be uploaded by Great Learning team. Um, okay, thank you.